So let's look at the second example. Okay, so same thing. You have to find out the relative extremum and the starter point. Okay, first thing that you have to do is you have to find fx. Okay, to find fx. Okay, so treat y as constant. So you differentiate this, you have 3x squared is constant 0, and then y is constant. Differentiate x, so you have plus 3y, and then find out fy. When you find out fy, same thing, you will treat the x as constant, so it's 0, and it's actually minus 3y squared. Okay, and then in here, you will have to treat x as constant, differentiate y, so you have plus 3x. Okay, so what is the next step? The next step is actually us to let the fx equal to 0. So you will have 0 here. So we have 0, 3x squared plus 3y. And simplify it, you will have minus 3x squared equal to 3y. And y is basically equal to minus x squared. So that is your first equation. Okay, then the second equation that is obtained from fy equal to 0. So we have 0 equal to minus 3y squared plus 3x. Okay, so in here basically you can do the substitution. Okay, so we're going to substitute number 1 into your number 2. Okay, so you have 0 equal to minus 3. Now your y here is actually minus x squared. Okay, and then you have y squared, right? So that's why we have a square here again. Okay, plus 3x. Okay, let's simplify it. So this is square. Okay, you square the minus, you become positive. So x squared, square it again, so you have x power 4. So you have negative 3x power of 4 plus 3x. Again, do the factorization. Do the factorization, you will have minus 3x. Okay, if you factorize minus 3x from here, so the things that remain is x power of 3. Okay, factor out minus 3 from here. What we will get? We will get minus 1. Okay, you can multiply back. If you multiply back, so you have minus 3 multiplied with minus 1 is positive 3x, right? So that is a factorization. Okay, so from here, so basically if you from here, so we have minus 3x equal to 0, x equal to 0. Then how about this? You will have x equals to minus 1 equal to 0, and x power 3 equal to 1, and you root it. Okay, you root 3 it. Okay, so we have 1. Okay, so once you have that, okay, so we interested to know the y value. So substitute back into here to get your y value. So sub your x equal to 0 into number 1. So then we will have y equal to minus 0 squared, that is 0. So you will obtain your first critical point, that is 0, 0. Okay. Then same thing happens to the next x. So the next x is you have to sub your x equal to 1, that you get it just now, into your number 1. So, okay, so you have your y equal to minus 1 squared. Okay, minus 1 squared. So this gives us minus 1. Okay, so the answer is 1 minus 1. So we have two critical points. So the first critical point, that is 0, 0. The second critical point is 1, negative 1. Alright, okay. Then what is the next step? So the next step says that you have to form the discriminant equation. Discriminant equation is getting from finding the second order partial derivative. Okay, so look at this one. You have to find these three first, then you form the equations by using this formula. Okay, back to our question. So our question just now, okay, we have these two. Okay, so first of all, let's just find out fx first. So you're going to treat y as constant, so you will have 6x. Okay, then in here you have to find y. Treat x as constant, is constant, and you have minus 6y. Okay, and then the third will be fxy. And this is actually reading the information from fx, and you differentiate with respect to y. So treat x as constant. So this is constant. Differentiate on this. So you have 3. Right. Okay. So now we're going to form the discriminant equation. So that is d equal to fxx multiplied with fyy minus with fxy squared. And this is actually give you 6x. This is actually minus 6y. And this is actually 3. Simplify it, you will have minus 36xy minus 9. So that is your discriminant equation. Once you have obtained a discriminant equation, the next thing that you have to do is you have to form the table. So the table that is consists of critical point. Your critical point that is 0, 0. And this one that is 1 minus 1. Okay. With the second column that is your d value. D value we can obtain from substitution the coordinate into this equation. But later we'll do it later, okay? And then the next will be the column of fxx. Fxx that is 6x, okay? And then we go to the conclusion. We'll go to the conclusion. So the conclusion. Okay. So first of all, okay. So let's do the substitution. Okay, let's look at the d value. So in here, you have the d value is getting from the equation d. Okay, do the substitute the value of xy in here. Look at the critical point. The first critical point, your x is 0, y is 0. You will substitute here. So you will have your d is basically negative 33 multiplied with 0, minus 9. To end up, so you have minus 9. Okay, and how about this? Okay, so this is actually ask you to substitute your x as 1, y as minus 1 into here. So you will have d equal to minus 36 minus 1. And so the x is 1, it's not minus 1, is 1. And the y is minus 1, minus 9. Substitute into here. Okay, so then you will have the answer as 27. Right? So once you have the d value, okay, let's look at the flow chart one more time. It says that if you get the d value that is less than 0, okay, you don't have to do this one. Directly we go to the conclusion. We say that it's saddle point. So in this case, you have a d value less than 0. It's negative 9 is confirmed less than 0. You don't have to find this. So the conclusion is saddle point. But for this one, you have 27 greater than 0. 27 greater than 0, that is your d value greater than 0. You have to look at the fxx value. Okay, because you either end with relative minimum or relative maximum. Okay, so this one is greater than 0. We have to check this. Okay, so now substitute your x value into here. So what happened to your fxx? That is 6 multiplied with 1. That is 6, right? So we have 6. Okay, so 6 is greater than 0. So if you got 6 is greater than 0, d is greater than 0, fxx is greater than 0, the conclusion is relative minimum. So in here, we will have relative minimum. Okay, so that is the answer for the second example. Okay, so we have classified the critical point. So we have one set of point and another one is relative.